We're on topic 19. We're going to see how Desmos can be applied here. And the first problem we're going to do is 1061H. Here's the problem. And you can see that I've entered it here into box number 1. And, I get a little triangle here. It doesn't like this equation. So what I did is I squared the left side of the equation here. I get this, and I squared the right side, and I get that, and it still doesn't like it. So what I did is I cross multiply, and x squared, this is 9 over 1, x squared times 1 equals 9 times x minus 2, and lo and behold, it gives me two solutions here, 6 or 3. Now, I can also get the solution graphically if I plot y equals x squared over x minus 2. And that is this graph right here. And then I look for the intersection with y equals 9. Here's y equals 9. And I get the values that x equals 6 or 3. So same as what I got by calculation algebraically. So I've got 6 or 3. I've got it one way and I've got it another way. We go on to the next problem. 1062L, and here we have 2x equals the square root of 5x squared minus 3x minus 10. Okay, got that. And it doesn't like this, but when I square this, I get 4x squared, and I square this, I get that. And now I get a solution, minus 2 or 5. And I'm going to plot it, y equals 2x right here. And y equals this, and look for the intersection. And the intersection, here's the straight line, which is y equals 2x. And this one here is the green one is y equals 2x, sorry, and the orange one is this one right here. So this one going down here and coming up here is the square root one, and the intersection of the straight line and the square root function is at x equal to 5, and that's the only valid solution. So x equals 5 is a valid solution. We previously discussed this. So this solution doesn't work when we put it back into the equation, but this does. So we can see that we can get the solution either graphically, calculated-wise, or graphically, and serves as a useful check. Again, if we go to 1073N, you can see equation in, and it doesn't like it. Get the exclamation point, little triangle here, Desmos calculated. So what we do is I transpose the root x to the other side, goes over here, and I get 3x. Then I square this side, I get 3x minus 8. I square this side. Now, this is 4 minus root x times 4 minus root x. The 4 times the 4 gives me 16. The inner and the outer combine to give me minus 8 root x. And I get plus x when I square this last term. So what I've done is square this, square that, it gives me that. Desmos still doesn't like it. I bring this over to the left side, transpose everything to the right side. The 8 and the 16 combine to give me the 24. The 3x becomes, with this x, becomes minus 2x. Still, no change. Desmos won't calculate it. Square this. 8 times 8 is 64. Square root of x times square root of x is x. And I square this, and lo and behold, I get the two solutions, 4 and 36. Now, if you go back, the only valid one that works in the equation is actually 4. 36 won't work if you put it back into the original equation. So here I plotted the left side of the equation. Here I plotted the right side of the equation. And the intersection is at x equals 4, which is exactly the same as what we got by calculation. So if you go back and you plug this 36 in here, it won't work. You'll get the square root of 100. 33 times 36 is 108, minus 8 is 100. Square root of 100 is 10 plus 6. Or plus, excuse me, the square root of 36. 10 plus 6. 16 doesn't equal 4. That's why this doesn't work. So only the solution 4 works, because you put here, you get 3 times 4 is 12 minus 8 is 4. Square root of 4 is 2. Square root of 4 is 2. 2 plus 2 does equal 4. Okay, let's go to the next problem. And we do some kinds of things. We're able to put the original equation here into here. And now what we do is we square this side, and we get this. The first term squared is this one right here. The last term squared is this one right here. And the inner and the outer combine to give you this. This squared gives you that. Desmos still doesn't like it. So what I do is I bring this x and that x cancel. I'm left with 4x. The plus 3 comes over here, and when it becomes minus 3, so we get 5 minus 3 is 2, and this term stays the same. So we just bring everything to the left side, and then equate this to 0. Doesn't work. Bring the root side to the left. Bring this to, okay, excuse me, if I bring this, this stays on the left, and I bring this on the other side, and then divide by 2 because I want to get rid of this 2 here. I get 2x plus 1. So again, if I square this, I get this, and I square this, I get that. Now I do get a solution. X equals 1. And if you put it back into the equation, you'll see that it works. I've done it by the graph. And so we look over here. This graph here and this graph, we do them independently, the left side and the right side of the equation. The intersection is at x equals 1, which is the same as this. So whether we do it by calculation right here or we do it graphically, we get the same graph. This line here, you can barely see it going over here like that, intersects. The orange line is this one that's going, going like this, right over here. And then right superimposed on top of it is this one right here. So the two lines are almost superimposed, but they do intersect at x equal to 1. Okay, this one, by the way, this is not a 3. This is the cube root of 3x plus 1, which translates to 3x plus 1 to the 1/3. So instead of writing this, I'm going to rewrite this, because I can't write the cube root into Desmos. So I write 3x to the plus 1. The 3x plus 1 has a bracket around it and is to the power 1. When you have this number here, it divides this 1 right here by 3. So this 3 represents this 3 right here. I bring the plus 2 to the other side, I get that. You'll notice that it doesn't like this at all. I'm going to jump to 4 because what I'm going to do is cube this. In other words, raise it to the, take this whole thing and raise it to the power 3, which will give me this. And if I do that and I do this to the power 3, I get that. And now this equation, 1 becomes 4. So the solution is x equals minus 3. I should have put this one right underneath. I don't know why I didn't. So anyway, but this one, not acceptable. I cube this side. I get 3x plus 1. I cube that side. I get this. This is the same as, imagine if this were a square root sign, then what there would be 1/2 here, and I would square this side and square that side. So here it's just a cube because this means the cube root of. Cube root means what number multiplied by itself 3 times. So you can see I get a solution of x equal to -3. Now I draw the two graphs, and I see where they intersect. Where do they intersect? At x equal to -3. So if you take 3 times -3, you get -9 plus 1, get -8. The cube root of -8 is -2. -2 plus 2 does in fact equal 0. Okay, find the points on the y-axis that are equidistant, are at a distance of 5 from the point 3, 5. So all I've done here is put this into the distance formula, and we've said 5 minus y, okay, equals 3 minus 0. Now why do we say 0? Because it lies on the y-axis where x equals 0. X equals 0 along this axis here. So when I do that, it won't work this out, but I square the left side. This is just an insertion point, so don't worry about it. I square this side, I get that, and I square this side, I get that. Now I get that y can be 9 or 1. So I put the points in 3, 5, which is this point right here. Put that in. I also put in 0, 9, and 0, 1. So here's 0, 1, and here's 0, 9. And you can see, you look at it, it does sort of, this distance from here to here looks that it's equal to that distance from here to here. And I plotted these points in table values in box 4 and joined the points. So I joined this to this, and I joined that to that. So, okay, now we're on page 108, number 9. Find all values of x so that the distance between the points x minus 1 and 2, 5 is 2 root 10. We use the distance formula. We say x minus 2 plus minus 1 minus 5 squared. I should say x minus 2 squared, and minus 1 and minus 5 squared equals to this. And when I put this into here, I get this. In other words, this applied into the distance formula simplifies to this, and this is the distance here. I square this, I get this, and I square 2 root 10, I get that. So I get two solutions, x equals 4 or x equals 0. So x can be 4 here, or x can be 0. So if I plot this, okay, this dark line is this line right here, and y equals 2 root 10 is this line right here. The intersection is at x equal to 0 and x equal to 4. So there are two solutions to this. So this completes our discussion on topic 19 and its application to Desmos.